All right, PreCalc. Here we are with 4.4. Trig functions at any angle. Okay. The definitions of our trig functions are restricted to acute angles before. In this section, we're going to open that up to cover any angle. Let theta be an angle in standard position with xy, a point on the terminal side, and r equals the square root of x squared plus y squared. Okay, so that's just a little a squared plus b squared equals c squared kind of a deal to get your r. Okay, so sine, here's what they're doing. Here's your triangle. Right? X goes over, y goes up, and then your r is the hypotenuse. So sine is always going to be opposite. So that's always going to be the y part over your radius. Cosine should always be adjacent to your angle. Okay? So x over radius. Tangent is going to be opposite over adjacent. It's all there. It's just that y is opposite, x is adjacent, and r is hypotenuse. Because r equals the square root of x squared plus y squared cannot be 0, you don't want r to be 0, it follows that the sine and cosine functions are defined for any real value of theta. Okay? However, if x equals 0, the tangent and secant are undefined. For example, the tangent of 90 is undefined because then it would be 0, 1. You'd have 1 over 0. Similarly, if y equals 0, cotangent and cosecant would not be defined either. All right, example 1. So how's this going to work? That's just a lot of math talk. Let's see how it actually plays out. -3, 4. So you just plot your point, -3, 4, and then draw your triangle. Okay? Now, some people like to do the negative. Some people don't. I like to put the negative on here. I know you can't have negative distance. You can't have a negative actual, like a side length in real life. But I put the -3 on there just so that I don't forget it when I'm doing my sine, cosine, tangent here in a minute. Okay, a squared plus b squared equals c squared. We got a 5 over there. Okay, and it wants sine, cosine, tangent. So sine, opposite, 4 over hypotenuse, 5. I know it's got the theta here. That's your rotation that it took to get there. And then this angle inside the triangle is what you're looking at. Cosine is going to be adjacent over hypotenuse. And this is where it's nice to have that negative there. -3/5. Okay, otherwise if you don't put -3 there and you just go 3, 4, 5 because technically you can't have negative length, then you would have to think a little bit at the end, oh, I'm in quadrant 2, this is negative and this is negative, so then you'd have to kind of like think through that. But if you just put the -3 there, it's really tough to mess up. And then tangent is opposite over adjacent, 4 over -3. The signs of the trig functions in the 4 quadrants can be determined from the definitions of the functions. Okay? Because cosine theta equals x over r, it follows that cosine is positive wherever x is positive. Okay, a lot of more math talk, okay? Sine, cosine, tangent, everything is positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3 because sine and cosine are both negative, so negative divided by negative makes a positive for tangent. And then cosine is positive over here in quadrant 4. A little saying for you, all students take calc. All students take calc. Okay? All obviously stands for all, everything. Okay? All students, S, sine is positive. Take, T, tangent's positive. Calc, C, cosine's positive. So there's just a little saying there to help you with that. Turn the page. if I can get it to unstick. All right. Given that sine is positive 4/5 and tangent is negative, where would that happen? Sine is positive here and here, and tangent's negative there, not here, there, so it must be in quadrant 2. 4/5. So that's the exact same one we were just on. 5, 4, a squared plus b squared equals c squared. We should recognize a 3, 4, 5. I'm going to remember to put the negative 3 on it there. Okay, find cosine. Adjacent over hypotenuse, negative 3/5. And then cosecant is the partner one for sine. So cosecant is going to be 5/4. All right. The values of trig functions of angles greater than 90 or less than 0, if you want to spin backwards with a negative rotation, can be determined from their values at corresponding acute angles called reference angles. So everything repeats outside of quadrant 1. It's the same stuff. It's all the same answers. It's just that the signs change, positive, negative. Okay, so if you can remember what's going on over here in quadrant 1, you can then apply that to all the other quadrants. All right, so let's say this is 150. No, what is that more like? That's probably more like 135, which leaves me 45 here. So this angle is going to be similar to 45 from over here. All right, you just got to take the answers for 45 and put them over here and just adjust the signs. Okay, this looks like it's 210. All right, that would mean this is 30. 210, 180, 30 more to get to 210. So this little guy here is 30. About, just totally making these up. I have no, I'm not like actually pulling these numbers out of somewhere. Just that it looks like it to me, that it could be that. And these are just easy ones to talk about. That this angle would be 30 degrees there. That gap between where the terminal side and the x-axis there is 30 degrees. So then this would correspond with 30 from quadrant 1, and then you would just have to adjust the signs. Same thing here. This looks like it's a gap of 30, so this was probably like 330 degrees rotation. Gap of 30 there. So it's going to be the same as 30 here from quadrant 1. Again, just adjusting the signs. Okay, find the reference angle. 300 degrees. 300 degrees, 90, 180, 270. So it's like right there. That's 300. What's left? 60. So this is going to be the same thing as 60 from quadrant 1. Its reference angle is 60 degrees. This is kind of a not very good one because it's an oddball radian. Okay, so they're asking you to follow these things up here. Pi minus theta, or theta minus pi, so 2.3 radians. Okay, if you draw this out, this is 0 pi, obviously. Pi over 2 is about 1.57, and then we have pi, which is 3.14. So 2.3 is going to be somewhere in here. So for quadrant 2, it is pi minus theta. And 3.14 minus 2.3 is about 0.84 radians. Not a very good one. Okay, it's probably going to be more like a pi over 2, pi over 3 kind of a situation. It's actually part of our unit circle. Negative 135. Can you count backwards? Okay, negatives are going to go this way. Negative 90. Okay, and then negative 135 is going to be right there in the middle. which leaves me with a positive. This is going to be 45 here, so this is going to be the same thing as 45 from quadrant 1, but then you just have to adjust your signs. I like to draw the picture. I think that's easier for me. Otherwise, you can do the little formula things there. Up to you. Okay, to see how the reference angle is going to be used in evaluating trig functions, consider the point x comma y on the terminal side. By definition, you know that sine is y over r and tangent is y over x. For the right triangle with acute angle theta and side lengths of absolute value x and y, you will have sine of theta prime over here, the inside one, is absolute value of y over r, and tangent is absolute value y over absolute value of x. So it follows that sine theta and sine theta prime are equal, except possibly in sine, because it's absolute value compared to just regular y or regular x. And the same is true for tangent and tangent prime, and for all the other ones. Okay? In all cases, the sign of the function value can be determined by the quadrant in which it lies in. Okay? Evaluating trig functions for any angle. To find the value of a trig function of any angle theta, determine the function value associated with a reference angle, and then, depending on which quadrant you are in, affix the appropriate sign. Okay, so here's a table. You guys are probably too young to have had Mrs. Olinger. We're probably getting to the people that haven't had Mrs. Olinger, but she was really big on this table. Maybe the other teachers that did Algebra 2 and Algebra 2B are really big into this table. If you had me, I was really big into drawing a picture of it, just a quick sketch, and then using your unit circle and having that memorized. Otherwise, this table can be very helpful if you have that table memorized for the basic ones here, and then you can just adjust the sign. These, I think, are pretty easy to memorize, the undefined zeros and ones. But those right here are pretty helpful, especially the tangent ones. Those are always tough to think about. All right, cosine of 4 pi over 3. I like to do the pictures. Okay, 4 pi over 3. There's 1 pi. 4 pi over 3 is going to be down here. Okay, so that would match with pi over 3 up here. So this is going to be half over, negative a half, and then negative radical 3 over 2 down. And we want cosine, that's going to be the first one, negative a half. Okay, how could you have done that with the table? 4 pi over 3 would be the same thing as pi over 3. We did that. Cosine is a half. And now you're in quadrant 3, so cosine is negative. So that's another way to look at that. Tangent of negative 210. Again, I like to draw the picture. Negative 90, negative 180, negative 210 is barely up there. So this, right here, it's always the gap between, that's kind of tricky. It's always the gap between your angle, where your angle stops, and your closest x-axis. So this is actually just going to be 30. So this is going to be like doing the tangent of 30, and then evaluating what quadrant you're in. Okay? So this is where this table does come in handy. After a while, you do this enough. Okay, tangent of 30. 30 has 30 begins with a 3, so its tangent answer has more 3's. Radical 3 over 3. The other answer for tangent is going to be 1. And then if you're doing 60, it doesn't begin with a 3, so it has less 3's. It's just going to be radical 3. That's how I kind of try to think about it. So this is going to be, it's 30 degrees. So it's going to have the one with more 3's, radical 3 over 3. And we're in quadrant 2, so tangent's negative because cosine is negative, sine is positive, so they're mixed. So tangent should be negative. cosecant of 11 pi over 4. My goodness. So it's kind of like sine of 11 pi over 4. Okay, that's a lot. Remember that a full circle is 2 pi, which would be 8 pi over 4. So we can kind of do a little math here. This is going to be the same as 3 pi over 4. 2 pi over 4 would be pi over 2. 3 pi over 4 we're over here. At negative radical 2 over 2, comma positive radical 2 over 2. Cosecant's related to sine. So but it's going to be the flip. So it's going to be 2 over radical 2, which should reduce to just radical 2. All right, last one. Let theta be an angle in quadrant 3, so they're already telling us that. And sine is negative 5/13. Quadrant 3. So we're going to be over and down and then back. 13. The hypotenuse is always positive. Sine is negative 5/13. Okay. I should know this. I'm embarrassed I don't. Well, let's do it. 13 squared is 169. 25, 144. So it's going to be 12. It's negative 12 over. There we go. That wasn't tough. It's 12, but we're to the negative direction, so I'm going to put negative 12 on it. Okay? So now we should be able to figure these out. Secant is related to cosine. Cosine would be adjacent over hypotenuse, negative 12/13. So then secant equals negative 13 over 12. Okay. Oh, we're supposed to use identities. I kind of cheated there, didn't I? Well, we have the picture, don't we? I think that was good there. We did cosine, and then we figured out secant from the identities. Tangent is sine over cosine. So we have negative 5/13 over negative 12/13. They didn't want us to draw the picture. We cheated there. I'll show you how else we could have got to stuff. Okay? Negative 5/13 over negative 12/13. Multiplied by the reciprocal. 13s cancel. Negative over negative is positive 5/12. Which we would have got over here. Opposite over adjacent. Negative 5 over negative 12 is positive 5/12. All right. It said using trig identities, so we weren't supposed to draw the picture. How else could we have gotten it? They gave us sine. Okay, sine squared plus cosine squared equals 1. So negative 5/13 squared plus cosine squared equals 1. So we got 25 over 169. We're going to change 1. Let's make our life easier because we know we're subtracting this on the next step. Let's make our life easier. 1, let's write that as 169 over 169. So then now when I subtract that over, we now have 144 over 169. Square root 12/13. We're in quadrant 3, so we know our cosine is going to be, it was plus minus, so quadrant 3, we're going to take the negative 12/13. And that's how we could have figured out our other piece before. So this is what we would have had, that cosine is negative 12/13. And now we go back to here, secant is the reciprocal of cosine. Cosine is negative 12/13, so secant is negative 13 over 12. Tangent, sine, they gave it to us. Boom, divided by cosine. We figured that out earlier. Boom, multiply by the reciprocal. So that's probably how we were supposed to do it. All right? Good luck there, kids. Make sure you're trying some of those problems and checking your answers with the answer keys online.